Alright guys, this is your instructor Mac and today we'll be discussing the next lecture. We discussed the concept of rebounding till rebounding in the last lesson. Today we are going to be continuing the concepts and well, we'll be starting off with some past present in the next lesson. So we'll be continuing the concept. There are some example questions that we have to discuss today. So a boy throws a stone vertically up into the air with the velocity of 6 meters per second. The stone reaches the maximum height and falls into the sea, which is 12 meters below the point of release. Okay, as shown in the figure. Calculate the velocity and time at which the stone hits the water surface. Okay, so we first of all need the velocity and the time at which the stone hits the water surface. So if the stone is thrown from here, it goes up and it goes down. The displacement that it is covering is going to be this. And this is very important concept. This point up, the velocity is positive. That means this is the positive region. So if it goes over here and then came down, when it's going up and coming down, at this point the displacement would be 0 again. And the total displacement that the object is going to be covering in this case scenario is going to be 12. First of all, I'll use SUVAT and I'll say the displacement is negative 12. Why negative? Because initial point going down the acceleration, the displacement is in the negative direction. This is something that a lot of students actually misses out and get the wrong answer. And moving on. The initial velocity is given, that's positive 6. Why I'm going to be taking it as positive? Because it doesn't matter. I've taken the whole journey into consideration. But why taking displacement as negative 12? Because in the whole journey, from this point to this point, the displacement is actually negative 12. Because it went up and it came down, then displacement becomes 0, and then it's negative 12. So I'm not going to be doing like I'm just going to take something else. It's going to be plus 6 for this point. Okay. Velocity, final, I don't know. I need that. Acceleration, I'm definitely no. There's no air resistance present and the upward velocity is positive, so acceleration is supposed to be taken as negative. Acceleration is going to be negative 9.81. I'm going to be doing V is equals to U plus AT, where V is going to be, I don't have the time again, sorry. I'm going to be doing SUVAT. I'll be doing S equals to V plus U over 2. I'm going to be doing V square minus U square equals 2AS. So I've got the final velocity. I need the final velocity. Initial is 6 is equals to 2. Acceleration is going to be negative 9.81. And the displacement is also going to be negative 12. So that's going to be 36. Plus 2 times negative 9.81 times negative 12, and the value will be equal to 270, and then I will have to root that. So the value is going to be V is equals to 16.5 meters per second. Now this is very important to be considered, that why did I take acceleration as negative? Because the object gained speed, at this point it became 0. And now the object would have been gaining velocity negatively. So whole part of the journey, the acceleration was supposed to be negative. This is something a lot of student misses out because usually the teachers tell them that downward direction, the velocity, the acceleration is going to be positive. Why the hell the acceleration is going to be positive? Acceleration would be positive in the case scenario where the speed is increasing positively. If I am taking upward direction as positive, that means once I reach this point, my velocity is going to be negative 0. And then when I go down, my velocity starts to increase in negatively. So this is something that's by far one of the most stupidest concept of the students. The students struggle with this a lot because we have made some stupid conventions that downward acceleration is positive, upward direction, I don't know what the hell that is. But you have to realize, if the upward direction is positive, that means acceleration is going to be negative. And if the upward direction is negative, that means the acceleration is going to be positive, and that's it. Same goes for the projectile that we'll be discussing in a few classes. Right now you have to realize, if upward direction of velocity is positive, acceleration is going to be negative, and that's pretty much it. Okay. Moving on. that time is needed. So I can use v again, v is equals to u plus at. Anything can be used now. So final velocity I already have, that's 16.5. Initially was 6, so it would be subtracted on this side. Acceleration I'll take as 9.81. So velocity value, final velocity would be negative in this case because the object is going down. So the velocity value is going to be negative. So yeah, because the object was going to be hitting the ground with downwards, so v will be negative 16.5. Acha. Since I took upward direction as positive, downward is must taken to be negative. All right. So negative 16.5 minus 6, and gravity I told you I'll be taking as negative 9.81 and then times t. Eventually your answer of time would already come to be positive divided by negative 9.81, and the time would come around 2.3 seconds. Time will be 2.3 seconds. This is something that's very important. Moving on, calculate the highest height at which the stone can be reached from the water surface. Okay, so from the water surface, if I need to get to the highest point, I can first of all assume that at the maximum point, the initial velocity is 6, the final velocity will be 0. Acceleration is again going to be negative 9.81, and I don't have the time. So I don't have the s as well. So I need the maximum height. I can use v square minus u square equals to s. Final velocity I've got as 0. Initially it's 6 to negative 9.81 is the acceleration, and I need the s value. So it's going to be 36 negative minus 36 divided by 2 times negative 9.81. I would get the value of 1.8 meters. But is this the answer? No. They need the highest height from the surface of the water. So from the surface of the water, I have to add 12 to this. The highest height would be 1.8 plus 12, which will be equal to 13.83. So the final answer will be 13.8 meters. That is going to be the highest height above the water surface. This was all just the basic revision for the SUVAT equation, but the actual concept was this, that we need to discuss. Sketch the motion of the graph of displacement time, velocity time, and acceleration time. Kids, as far as displacement time is concerned, since upward velocity is positive, there was a positive displacement for the first part, and since it was decelerating, the graph is going to go look somewhere like this. Then the object came down, the graph would go like this, and then the object went more further down. That means the displacement would like go on, and then the object would like go like this. So the graph is going to be somewhat like this. I hope this makes sense. The graph is going to go in the negative quadrant because the object, once like this part of the journey is like the maximum height, then this part of the journey is coming back to its original position. Then since it's going down, the displacement would be covered in the negative region. Extremely important. Well, it goes for the velocity time graph. Initially, the object is coming to rest positively because the upward direction was taken positive by the exam. In the question, it was given as starting was plus 6. So plus 6 eventually became 0. And then when it changes direction, the velocity starts to be like in negative, and then it would be covered in the negative quadrant because the object is going to be moving downwards, and then it would go a little further than before because it's going to like come back over here. It's going to be negative 6 and then again increase that value, and eventually it was reaching around negative 16.5. So yeah, the graph is going to go like this. But what happens to the acceleration? It's going to stay the same. If you realize throughout the journey, acceleration is always going to be negative 9.81. Acceleration magnitude is not going to change. Acceleration will throughout be negative 9.81. This is extremely important that you realize this. These questions have been asked a lot of time in your examinations. There's no, what do we call it? Like leniency regarding this. You have to be very clear, otherwise you'll lose the marks. Moving on. Last, we have got a couple of concepts regarding what would the graph look like when there's a resistance present, and we'll conclude this lecture on this point. In the next lecture, we're just going to be doing passovers, all passovers. So next couple of lectures, they're all regarding passovers of this motion graphs. Okay, so they're asking about graphs with air resistance. So first of all, with air resistance present, the displacement time graph is not going to change. It's going to look exactly the same, because whether it's air resistance or not, it's going to be like this. And if they eventually reach terminal velocity, the graph is going to like go a straight line. So it's still accelerating. Even if the object is going down, it will be accelerating. And might be possible they ask you about in the negative as well. Might be possible. Like I've seen the passovers, they are asking this. So this is going to be the shape of the graph. It's still accelerating. If the downward direction is taken as negative, so this, if the option is not, this option is not there, that means this option is 100% correct for a displacement time graph that is falling under the influence of air resistance and accelerating. All right. When it comes to a velocity time graph, yeah, the velocity time graph is going to be looking like this. And this point is sometimes called as terminal velocity, because there's decreasing acceleration. There's no way to draw decreasing acceleration or a displacement time graph. So there's decreasing acceleration. All right. When it comes to acceleration time graph, the acceleration time graph, like there is no actual shape for that. But yep, you can say the acceleration is going to decrease. What rate is going to decrease? It can be somewhere like this all can make sense. But let's say it's decreasing at a uniform rate. Each second it's decreasing uniformly. So this is going to be the graph of acceleration against time. Initially, let's say acceleration was positive and then it was reducing down. The gradient of acceleration time graph would be reducing. So this graph can go like this as well. So that is basically the concept of falling from with air resistance. Last is the concept of acceleration time graph. I'm going to be discussing one last thing, that's acceleration in meter per second square and time in seconds. If there's an acceleration time graph that is drawn, the acceleration time graph's area under the graph, since acceleration is equals to change in velocity over time, so acceleration times time actually gives us change in velocity. So the area of acceleration against time graph gives us change in velocity. The gradient does not give us anything that we need. So area of a acceleration time graph basically gives us change in velocity, not gradient, change in velocity. So if I've got acceleration that's 30 meters per second square and time is 3 seconds, that means 30 times 3, object is changing its velocity by 90 meters per second. So that's pretty much everything that we have to discuss before moving on to the passovers. Guys, the next lecture we're going to be doing a lot of passovers from 2015, 19, 20, 21, 20, 20, 24, 25. All those questions one by one. Still, I think they're going to be covering 2 more lectures in the passovers concept, because I'm going to be going in a lot of detail when I'm going to be discussing those passovers. Anyway, make sure that you're done with the lectures so that we can actually understand the passovers. Okay, see you in the next lecture. Take care, guys. Since you're enjoying the lectures, just wanted to inform you that there are premium batches going on. That is direct way to get A's and A stars. It has got some exclusive content that is not generally available neither on the website nor on the YouTube. So you can join the batch to get your grade.